Let's try the next example. Now this example asks us to find y double prime in terms of y. So we need to take the derivative twice. I want you to start by taking the first derivative on your own and remember your hook-on factors. So here's your equation. Try to take the first derivative in parts and then simplify it and solve for y prime or dy dx. Ready, set, go. You should have gotten negative x over y when you take the derivative, solve for y prime, and simplify it. Now I want to take the derivative again. I'm going to get y double prime. Looks like this time we're going to have a quotient rule. So remember with the quotient rule, I list both of them, list their derivatives, and with quotient rule I start on the right, y times negative 1. Quotient rule is a minus. Then I do my other cross. All divided by the second one squared. So I've got y double prime is going to equal negative y plus xy prime all over y squared. Now, you would think that we should be done, except if you go back to the problem, it says in terms of y. That means you should only have y's in your answer. No x's, no y primes. So what we're going to do is be a little tricky on this one. Now, the first thing I'm going to get rid of is my y prime, because that's the easiest one to get rid of. Instead of writing y prime, I'm just going to substitute what y prime is. So y prime is negative x over y. So now I've gotten rid of my y prime. Sweet. I'm going to simplify this. Minus x squared over y all over y squared. Next thing I need to get rid of is my x. And once again, I'm going to be a little tricky about this. I want to substitute x squared. Well, my original equation was x squared plus y squared equals 3. So then I know that x squared is going to be 3 minus y squared. Just bring it over to the other side. Well, if x squared is 3 minus y squared, then I can substitute that in for x squared. And now I have the second derivative in terms of only y's, nothing else. So that is my final answer. Let's do the last example. I want you to start this example on your own. Take the derivative of each part individually, and don't forget your hook-on factors where you need them. So try that out and then solve for y prime. This is what you should have gotten. Derivative of cotangent is negative cosecant squared of y, but then we need to add our hook-on factor, y prime, or dy dx, equals derivative of x is 1. Our hook-on factor for x is dx dx, so we don't really need it. And then minus y prime. Derivative of y is dy dx or y prime. Now I'm going to bring everything that has y primes to one side. So that's all my y primes. Everything else that doesn't have a y prime on the other side. So then I can factor a y prime out. And this is what I'm left with. Divide by what's left. So then I have y prime by itself and then everything else on the other side. Now, if this is a free response, you could totally end there. But if this is a multiple choice, your final answer might be different. And that's because 1 minus cosecant squared of y is a Pythagorean identity. 1 minus cosecant squared of y is actually negative cotangent squared of y. And then 1 over negative cotangent squared of y is negative tangent squared of y. So if this was a multiple choice, your multiple choice answer might actually be tangent, not with what you came up with. So that is everything with implicit differentiation. You are good to get started on your assignment.